Listen, I'm doing something, and I don't know if I'm going to be able to do it a second time. So I'm just doing this video for myself, just so I can actually watch how this all works. Let me see if I can get this down here. Okay, now in the first scenario, okay, this is a 5 dice, but I don't want it to be a 5 dice, so I'm going to redo it. I'm going to redo this dice just like this, and I'm going to put a center dot and make it the ace dot. Okay, now the first thing, okay, I want to do is, if this is the reality of the one world, okay, this is what we're going to do. Okay, there's an area here, an area here, an area here, an area here. 1, 2, 3, 4. What do we call the value of these? We call the value of these 4. Every one is valued at 4. So when you get a whole area, it's 4. So you have 4, 8, 12, 16. 4 times 4 equals 16. And the center value is only the value, okay, of half, one part of the moon, okay, of the center of both of these. It can eat up a corner here and a corner here. The circle, which is the only way to make this circle, and the smallest circle you can make, okay, I cannot do this to make the circle, okay, so I make the whole circle. I go down to here and down to here, over to here. Now, we would have the frame of the house at this time, okay, and I'm going over to here, and I'm going up to here, and I'm going over to here, and over to here, and now it ends. Why does it do this? Why is this the Fibonacci? Because what happens is I go up, exactly it should be like this, okay? I go up 1 and 1 over. So I go up 1 and 2 over, down 2 and 1 over, okay? Down 2 and 1 over, and then I go, I'm supposed to be this down 2 and 1 over, 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 and then I come inside my tail again. So let's do this Fibonacci thing one more time. Let's get a fresh page, okay? Let's get a fresh page, okay? We're going to start from here. We are inside. We are inside the nut. So I go here, 2 over, 1 up, 2 over, 1 down, 2 over, 2 over, 1 across, 2 over, 1 across, 2 over, 1 across, 2 over, 1 across, and I keep going up, 2 over, 1 across, and I go 2 over, 1 across. This is what it makes right here. From here to here is 1, from here to here is 2, from here to here is 3, from here to here is 4, from here to here is 5, from here to here is 6, plus 1 equals to 7. This is the circle of the 7th gate ring. Now you have to do the same thing again. Inside, okay, you have to watch. Don't forget the value of every square. The reason a square is that value, okay, where are we? I'm not liking the lighting right now. Okay, the reason it's like that is because this square it's in its own house. 1 part, 2 part, 3 part, 4 parts. But in the secondary, the x has to come here and to come here. In both scenarios, on both angles of straight, okay, and now we have to recreate the same design, but this way. We created this design this way. It creates in itself as 4. This one over here, well, it's 4 and then the surrounding, everything that surrounds it. Everything that surrounds it, okay? Everything that surrounds this. So it's 4 areas to 8 that goes around it, 4 and 8. In this scenario over here, you now have the area space that this eats up the area space. This eats up the area space. Okay? This is the void between the bricks. This is right here, this space. This is right here, this space. It has to be over here. Otherwise, you're talking for it to be over here. See, this way is going across. This way went up and down. This way will go up and down. Here is your 2 dots. Now if we continue, and it's always by 3, right? Because how does this value? This is the value. This is the value. This is 2. This is 5. This is 8. This is 2. 2, 5, 8, 2, 5. Wow, I can't even do it now. The area space is supposed to be 2, 5, 8. 2, 5, 8. This is the cement. Okay, the cement. 2, 5, and 8, and 4, 5, and 6. Let me show you it again. This is 4. This is 5. This is 6. When this one comes from here, okay, and goes down over here, this would be 2. This would be 5. This would be 2. You see, I'm just trying to understand. This way is 4, 5, and 6, right? 4, 5, and 6, 4, 5, and 6. But this way, or is it this way? This brick to the middle of this brick to this brick. So you have to go down 1, 2, and over 3. I'm not liking this video, but that's not what I'm here for. What was an something in my eye? You know, we got to remember, this is a brick and this is a brick. In between is the cement. So you go to the brick, in between the brick, and then you go to the cement. And then 4, 5, 6. So I'm not even counting the layers of cement up, but I am counting the separation. That's funny. Did you see what I did? I counted a brick. Wow. Okay, let me rehash this whole thing. I built the 3-ring circus. I'm going to get back to this. So if I build this, let's do it one more time. I go here, up 2, up 2, up 2, up 2, 2, 2, and this one, I end up over here. Look at that, the barnyard, eh? The barnyard. It comes exactly out to the barnyard. Look at that, the number 6. I do it on the inside. Over 2 and up 1. Over 2 and up 1. Over 2 and up 1. Over 2 and down and over 2. 1, 2 over and down 1. Over 2 and down 1. And I got the number 6. I got the ring and the 6. 60. And what do I get inside of this? If I'd have to do this, this is an exact design. There is no mistake, and there cannot be any mistake. The only way to do this now is, where was my point of departure? Yes, my point of departure was out here. Okay, I have to take away this point, disregard this point. What am I left with? I am left with this exact image. Okay, can I crisscross anything? Yeah, I probably could crisscross things. I could have did something different. Let me do that again. 2 down here, and 2 over here, and 2 over here, and 2 over here. There's the box. Now I went 2 over here, and 2 over here. So you have the house, the 6, the barn. These are all special angles, my friends. These are all special angles. These are not square. These are dimensional angles these people were drawing. These people were doing the artifacts. They're all dimensional angles. If it's a flat angle, bubble it out. If it's a dimensional angle, it'll tell you the side. When you take this into 4 areas, 4, 4, 4, and 4, that's 16. You're only taking up 1/4 of each one inside the round, right? So if that was 16, the value of this would be 4 plus its own size, because it comes in its own block. This circle comes in its own block. You don't have the middle of the tire without a rim. It comes in its own block, its ring, its motor, its piston. The piston has a hole inside of it. So in order to put this to the hole, this one is already one block size. So all the corners of these four areas, because it splits into four, one of these is gone. It only comes in with three sides. It doesn't come in with a fourth side. The fourth side is an empty space. So you take up a whole block in here. So now you have to take this block. So you have to take this block and you have to rebuild the block. Is that the block he comes in with? Yes, he comes in with the big block because then you get to use the little block. Here's the little blocks. Here's the little blocks. With little blocks around the big blocks to making sure we got the big brick boxed in. Make a nice, beautiful design. There you go. So we block that in. Okay? This is its own space already. You cannot own this space. You own this space of the blocks. Otherwise, you have no in. So this taking up one actual block of four areas, okay, 1/4 times 1/4 equaling to 1. It also becomes the area it is, which is 5. A, E, and O. A, E, and O creates I. 5, 9, 5. 5 fingers, 5 fingers, 4 fingers, 4 fingers, make 9. You got to put 2 together to extend, the extension. If there's 4 ends on 2 extensions and 2 come together, you only have 2 left. Then if you add a third one, if you have 5 extensions, 5 extensions have 10 ends, but at the end you only have 2 ends. 5 extension wires times 1 and 1 tail and a head. Plug together. You have a head, a tail, a head, a tail, etc. And then you'll have just a head to a tail. So you'll have 2 out of what was 10. The blue balls in pool. Blue pool. 10 and 2 equals to 16 and 2, which is 18. 16 minus 2, which is 14. 1 times 6, 1 plus 6, which is 13. 7 minus 2, 7 plus 2, 7 divided by 2 is 3.5. It's a perfect divisible. When you end up with a 5, it's a perfect divisible. When you end up with a 0.25, it's a perfect divisible. When you end up with a 10, it's a perfect divisible. Do you want to know why? Because we got all of these numbers in our change in our pocket. So if we can make the change in our pocket, they'll always work. The 2 number, I'm talking about 2, dividing things by 2. You want to divide a quarter by 2. It cannot be done. You cannot divide a quarter by 2. It's 12.5. It creates a third world. Now, so the quarter is a prime number in this situation. So the actual answer for what we were looking for is how many boxes inside of this area, the area space that we take up. Well, I just want to show you something, that if the real size of an area place is actually this size, from this size square, this owns all of this. This area, this area, this area, these areas are all valued at 5 each is 45, and 9 each, which is equal to 81, because there's 81 areas to play. So this one here, okay, through its heart would go up here, and through its heart would go here. So the actual thing is, this one gets 4, 3, 6, 9, 12. 4 versus 12. Purple in pool. So the 9, purple equals to the value of 9. So that's a birth. Did you understand what I did? This entry that eats up from this entry on the outside, becoming that ball, running like a radiator, flinging them all together at the same time. They're never apart with that ball. They're never apart with that ball. Anyways, Raphael, 7286 in the constellation of Pegasus. It's not a good video. But it's okay, my eye was hurting. It's never okay. An excuse? An excuse? No. An explanation with reason. For if the question is asked, do you have explanation with reason? I give my explanation with reason. Don't tell me it's not good enough. Just think into your mind and ask if I have any more or if that will be sufficient. You know yourself if that was enough. Thank you.